Hello college algebra student, this video is for chapter 5.7, inverse of polynomial and rational function. We'll go through how you can find inverse of polynomial function, how to find inverse of actually a radical function also, and radical function. We have gone over inverse function basic in chapter 3.7, so we just want to go over this briefly. If f is a one-to-one function, only one-to-one function has an inverse. So if I have a f of x is a one-to-one function, then f to the power -1 written that way is the inverse function. So this is not 1 over f of x. It's just f of -1 is a notation of an inverse function. Properties of an inverse function is if you composite, so if you go from x to f, like in here, you put x into f, to f of x, and so this is y, and you put this whole thing into f inverse of f of x, it turns out that this is actually x, because f inverse cancel everything that you have done on f of x. So you can think of f inverse as the canceling function, so that when you start out with x, you end up having x. The same thing for a different order. If you have x and you have it put into the inverse, and it become a y of the inverse function, and then you have it put into f, it turns out that you go back to x. So this is the idea of the inverse function. And because they switch x and y, so f inverse go from x to y, or f go from x to y, whereas this inverse go from y to x. So their domain and range switch. So the domain of the original function become the range of the inverse function. Range of the original function become the domain of the original function. So let's do part 1, which is find inverse of a polynomial function. Some key that we need to know is the inverse of a polynomial function become a radical function. So if you start with a function that has x squared term, the inverse would be, it would associate with an inverse of square root x, because that's how you get rid of it, right? Become x. And if you have an x cubed function, the inverse is a cube root function. So we'll go over these two are the toolkit function. We'll go over how to do that. Basically, and also another key is if the degree of the polynomial is even, we have to restrict the domains to make the function a one-to-one, because in an even function, usually they go up and down to the same infinity or negative infinity. So if you do a horizontal line test, it doesn't pass. The steps to find inverse is still the same. You write f of x as y. You interchange x and y, and you solve for x. Now you can switch these two. You can say you can solve for x first and then switch later also. So both are okay. After you solve for x or y, and after you switch, and then you rename the y as f inverse. So let's do a few examples on just this. So what are the toolkit? In the toolkit function, there's two polynomial functions, so we'll find the inverse of them. Now, let's do x cubed first, because x cubed is pretty straightforward. So I have g of x equal to x cubed, and I want to find the inverse. Now, because it's x cubed, the domain, it is already a one-to-one, and the domain is all real number. So we don't need to worry about having to restrict domain. So the first step is to write the function as y equal to x cubed. Replace it with the y. And then you switch x and y. I like to switch first. This is the first step. And the second step is I like to switch x is equal to y cubed. And then I concentrate on solving y. So how do I solve y? Oh, just do the cube root, right? Of y. And then for cube root, I don't have to do plus and minus. It's just one number. And there I have. The fourth step would be write this y as f inverse, or this in this case is g inverse of x, is equal to cube root of. And domain is all real number. If it's all real number, you don't have to write anything. Now what about f of x equal to x squared? So I write f of x equal to x squared, and I think about, oh, do I have to restrict the domain so that it become an inverse one-to-one function? Yes, because inverse are like this, right? So I have to get rid of part of it. So maybe I'll restrict the positive part. So I would be just looking at this side. And if because of that, where would y be? Y would always be greater than 0. Also, you see how these y's are like that. And now this would become the domain of the new inverse function. So you write the domain and range. Now you're going to do it. Step 1, y equal to x squared. Step 2, switch x and y. X equal to y squared. Step 3, solve for y. So I have to do plus and minus, presumably, but because y is always positive, so I don't have to do minus now. I just do positive. And then 4 would be write it as f inverse of x is equal to square root x. And you should also say the range become the domain, so x is greater than 0. Okay, so the new domain is the range of the original function. Second example, this is not a two-kit function, but a kind of a transformation of the quadratic function, x minus 4 squared plus 3. And we already restrict the domain to be 4 to infinity. So if I only want to have positive number here, I would know that my range is, so this could only be 0 as the lowest. And anytime you have a number that's higher than 4, it would be greater than 3, right? So 3 is the minimum. Or you can tell that the vertex is 4, 3, so and it is open up, so 3 is the minimum for the range. You write the range so that you know that the domain of the inverse is this. Okay, so now I do step 1. Instead of writing f of x, I write it as y equal to x minus 4 squared plus 3. I want to do switch on x and y now. So switch x and y. So become y minus 4 squared plus 3. Now I concentrate on solve for y. Now this would involve more step. So I want to do the square root here, but I have to clean up anything that is not the square first. Y minus 4 squared. Now I have a square and I can do the square root. So this is still, so square root of x minus 3 equal to y minus 4. So I don't have to do plus and minus because I know my y has to be greater than equal to 3. Oh no, the range is from 4, so this will be always positive. So the range is the domain. So 4 minus 4 is the lowest, is 0. So I'm done. I don't have to do plus, right? So I have to solve for y. So this is not done yet. So get rid of the 4 on the other side. So square root of x minus 3 and a plus 4 outside. So this is the step that I want, that I'm done. And I'm going to write the inverse function. Replace y by the name of the function, which is x minus 3 plus 4. As you can see, the domain is the range of it. You should mention that x now is greater than equal to 3. Just the range become the domain. The next one is the inverse of a cube function, which is 7 minus x cubed. So we don't need to restrict domain because the cube function is 1-to-1. So there's no domain and range to say. So they're all real numbers. So default, we don't have to say anything. So we just start to step 1, write it as y equal to 7 minus x cubed. This is very similar to 3.7. So then switch, right? So x is equal to 7 minus y cubed. I want to solve for y. So I want to get rid of the 7. So this is solve for y is x minus 7 equal to negative y cubed. I need to do the cube root, but I don't want anything over there. So I multiply negative 1 on both sides. So it becomes negative x plus 7 equal to y cubed. Basically multiply negative 1, multiply negative 1, right? Now I can do the cube root. Y would equal to cube root of negative x plus 7. That's the That's the end of the third step. I solve for y. And then the fourth step is you just write it out in it is g. G inverse of x is cube root of negative x plus 7, or you can write 7 minus x. And we don't have to write the domain, it's all real number. So the next part is find inverse of radical function. Radical function. Radical functions was the inverse of the polynomial, so you can kind of deduce that if you have a radical function, is the inverse is polynomial, right? So because to get rid of the radical, you do square or cube or something. So the first thing you do is to determine the range. So whenever you do a radical function, especially if it's an even radical, you assume that this is always positive, right? And so positive plus 5, that means the range is greater than 5, right? The range is greater than 5. So determines the range. Determine the range of the original function first, and then do the 3-step process or 4-step process. We place y, solve for y, restrict them, solve for x, and then switch. I think we should also switch x and y. Switch x and y. You can do switching x and y first and then solve for y, or you can solve for x and then switch x and y. So let's do this example. I have a radical function. So first is 6x minus x plus 5. So this is a one-to-one function. The minimum of this is 0. So you can say that the range of this function must be y greater than or equal to 5, right? The lowest you can get is this. It's an even root. So let's do the step to find the inverse. Y equal to square root of 6x minus 8 plus 5. I want to get rid of this by squaring it. So I want to do second step, switch x and y. X is equal to 6y minus x plus 5. So solve for y now. The third step is always solve for y. So x minus 5, get rid of them. 6y minus 8. Okay, so we can do it now. So we can just continue to solve how to get rid of the square root. We want to square it, right? So now 6y minus 8. And then we want to solve for y. So this is easy. You just get rid of the 8 and then divide it by 6, right? So just do both steps at the same time. So get plus 8 first, and then the whole thing divided by 6. That would be my y. And then the last step would be write it as an inverse. Inverse of x is equal to x minus 5 squared plus 8 over 6. But the original function has the range of y greater than 5, so you should say the domain is of this new inverse function is x has to be greater than or equal to 5. And then that's the inverse. Do I have time to finish this one? So the last one is a cube root function. I want to find the inverse. So step 1 is I don't have to restrict any domain. I don't need to find the range. They are just all real number, right? So cube root, cube are easier. So I would say y is equal to 3 minus 4 cube root of x. Then the second step is switch x and y. X is equal to 3 minus 4 cube root of y. The third step is the most important one, is to solve for y. So how do you solve for y? You have to clean up everything outside. So first, minus 3 first. And then I have negative 4 cube y. I have to get rid of the negative 4. It is not by subtracting, it's by dividing. So you would say x minus 4 over negative 4, because this is a multiplication, right? So I have a cube root of y. So now I can cube both sides. X minus 3 to divide by negative 4 to the power 3 is equal to y. Now I finish solving. So f inverse of, it is g. G inverse of x is equal to x minus 3 over negative 4 cube. That's it. So we'll do part 2, which is the inverse of rational function.